Good morning. Our lesson today is about matter construction. What is the meaning of matter construction? The matter consists of what? What is the smallest part of the matter? This is the title of our lesson today. Matter construction. The matter consists of what? We studied before our body consists of systems. These systems consists of organs. These organs consists of tissue. This tissue consists of the cell. So the cell, it is the smallest part of our body, the cell, smallest part of our body. So the cell, it is the building unit of the body. So the building unit of our body is the cell. Like any building consists of walls. This wall consists of a brick. So the brick is the smallest part of the wall. So the brick, it is the building unit of the wall. Like the matter. How about of the matter? The matter is consist of small parts. These small parts or tiny parts called molecules. So the building unit of the matter is the molecule. So I said the building unit of the body is the cell. The building unit of the matter is the molecule. Something is called molecule. So what is the meaning of the molecule? The molecule, it is the building unit of the matter. It is the smallest part of the matter. Building unit mean smallest part of this thing. So the molecule, it is the smallest part of the matter which can exist freely and it has the properties of the matter. What is the meaning of that? If you have a matter, this matter, if you have a matter like iron, this is a piece of iron. A piece of iron consists of small parts or is divided into small parts. These small parts, the smallest part of this matter called molecule. So the molecule, it is the smallest part of the matter, or it is the building unit of the matter which can exist freely. What is the meaning of which can exist freely? I mean, I may find the molecule alone, the molecule of iron alone. So it can exist freely and it has the properties of the matter. One molecules of the iron have the same properties of this piece of the iron. So the definition of the molecule, it is the smallest part of the matter which can exist freely and have the same properties of the matter. One molecule of the iron has the same properties of the piece of iron, or 100 gram of iron. Okay, so the molecule, the smallest part of matter which can exist freely and it has the properties of matter, and it is the building unit of matter. So the cell, the building unit of the body is a cell, the building unit of the matter is the molecule. To show the matter is composed of molecule, to approve the matter is composed of molecule, if you have a beaker, this beaker contain a perfume. Before this activity, if you measure the mass of this beaker containing the perfume, you will find this mass is 100 gram before the activity. Okay. After this, you will put this beaker in one side of the room. You will put it in one side of the room. If you have a beaker and you will put this beaker in one side of the room. Okay, the beaker is open, containing a perfume, and you will move to the other side of this room. After a period of time, you will smell the odor of this perfume. After a period of time, you will smell the odor of this perfume. While this speaker in one side of the room, and you move to the other side of the room, but you will smell this odor of the perfume. And after the activity, if you measure the mass of this beaker that containing the perfume, after the activity you will find it is 95 gram, but before the activity it uh, It was 100 gram. Why? Because this perfume is consist of molecules. These molecules is move from one side to the other side and reach to your nose to smell this odor. This molecules of the matter. It is the building unit of the matter. So why the beaker containing a perfume before the activity is 100 gram, and after the activity its mass is 95 gram, its mass decrease. Why? Because some molecules of this perfume move in the through the air to the other side, so its mass decrease. So we can conclude that the matter in any state, solid, liquid, gas, is composed of a small building unit called molecule, and these molecules have the same properties of the matter. Why? Because I smell the odor of the perfume. So all perfume has the odor, and some molecules has the odor. This odor is the same. So some molecules or the molecules have the same properties of the matter. So from this activity, we can conclude that matter in any state, solid, liquid, or gases, is composed of a small building unit called a molecule, and these molecules have the same properties of the matter. Number one, let's answer this question. What is the building unit of matter? The building unit of matter is molecule. Number two, while the building unit of the body of living organisms, the building unit, the smallest part of the body of living organisms is cell. The properties of what of perfume are the same properties of 100 gram from it, the properties of one molecule. The properties of molecule of perfume are the same properties of 100 gram from it. So I smell the odor of this perfume in the other side of the room. So this activity showed us the matter is composed of molecules, and these molecules have the same properties of the matter. Let's start to the next point. This next point is the properties of the molecules of matter. What are the properties of molecules of matter? Any molecule has three properties. Number one, molecules of matter are in a state of continuous motion. Number two, there are intermolecular spaces among the molecules of matter. Number three, there are attraction forces among the molecules of matter. We will study each property of these properties of the molecule. Let's start with the first property of the properties of molecules, and it is the molecules of matter are in a state of a continuous motion. To prove that the molecules of matter are in a state of a continuous motion, this is the first property of the molecules. The molecules are in a state of a continuous motion. What is the meaning of that? If you have a beaker and this beaker containing a water, okay, this beaker containing a water, and you put some drops of permanganate matter called permanganate inside it, some drops of permanganate inside the water. This permanganate, this color of the permanganate is a violet. You will find that the color of the water become violet. Why? Because this permanganate or this matter consists of molecules, and the molecules of permanganate are in a continuous motion, until all the color of the water become violet. Okay, so the molecules of matter are in a state of a continuous motion. So this activity, if you have a water and you put some drops of permanganate inside it, you will find that this water will it change the color of this water, will it change to violet color. Why? The color of the water will change to violet color. Why? Because the permanganate or the permanganate is a matter, and this matter consists of molecule, and the molecules of any matter are in a continuous motion. So it will spread through the water until the color of the water become violet. So we can conclude that the molecules of matter are in a state of a continuous motion. Another example, if you have a water and you put some ink drops inside the water, you will find that the color of the water becomes the color of the ink. Why? Because the ink or the molecules of ink are in a continuous motion. Because the molecules of ink are in a continuous motion in all direction among water molecule. So why if you have a water and you put some ink drops inside the water, you will find the color of the water become the same color of the ink. Why? Because the ink is consist of molecules, and these molecules are in a continuous motion. So the molecules of ink are in a continuous motion in all direction of the water molecule. Another example, when you leave the perfume bottle open in one side of the room, this perfume bottle open in one side in the room, and you are in the other side of this room, you smell the odor of this perfume. Why? Because the molecules of perfume are in a continuous motion until reach to you in the other side. So you you smell the perfume. Why? But because the molecules of the perfume are in a continuous motion and have the same properties of all perfumes, so you smell the same smell of the perfume. So this activity shows that the molecules of the matter are in a continuous motion. So as we said, the matter consists of molecules. Some small parts is called molecule, and these molecules in a continuous motion. Why? When you put some drops of permanganate, that color is a violet in a water, you will find the all color of the water become violet. Why? Because the molecules of this matter permanganate are in a continuous motion. If you have a water and you put some drops of ink inside the water, you will find that all color of the water become the same color of the ink. Why? Because the molecules of the ink are in a continuous motion. If you leave a perfume bottle open, you smell it all over the room. Why? Because two properties. Number one, because the molecules of the perfume are a continuous motion. Number two, because the molecules of a perfume have the same properties of a perfume. Okay, this is the first property of the properties of the molecules of the matter. Let's start. Let's oh uh, the molecules of solid matter have limited vibrational motion. What is it? I said before, any matter consists of molecules, and these molecules are in a continuous motion. What is the meaning of all molecules of matter are in a continuous motion? I mean, if this solid matter, the molecules of the matter have the motion, the molecules of liquid have a motion, the molecule of a gas have a motion. Okay, I see the motion of liquid, and I see the motion of gases, but I can't see the motion of solid matter. If I have a piece of iron, I can't see the motion of molecules of it. Why? Because the motion of the solid matter are a vibrational motion. What's the meaning of vibrational motion? In its state, its motion in its state, around its state. So I can't see it, but the solid matter have a vibrational motion. The molecules of the solid have a vibrational motion, but I can't see it. Why? Because it is a vibrational motion, but I can see the motion of a liquid. I can see the motion of the gas. The motion of a liquid is more free, and the motion of a gas is a completely free. Number two, in the properties of the matter, the molecules of the matter. Number one, molecule of matter are in a state of a continuous motion. Number two, there are intermolecular spaces among the molecules of matter. What is the meaning of intermolecular spaces among the molecules of the matter? If you have a matter and this matter consists of molecules, this molecule and this molecule, there are a spaces between these molecules. This space called intermolecular spaces. This is space called intermolecular spaces. Why? Because it is a molecule, so it is called intermolecular spaces between the molecules. So it is called intermolecular spaces. How we approve that there are intermolecular spaces between the molecules of the matter? If you have a 300 cubic centimeter of the water and you have 200 cubic centimeter of ethyl alcohol, before mixing, I wanted to calculate the volume of the water plus ethyl alcohol before mixing. So the volume of the water is 300 before mixing, okay? The total volume of the water and ethyl alcohol before mixing, and the volume of ethyl alcohol is 200. So the total volume of the water and the ethyl alcohol before mixing is 500 cubic centimeter. Okay, this is before mixing. But after mixing together, after put the ethyl alcohol on water, if I want to calculate the volume of this mixture, I will find it is 488. This is a practically after I put the ethyl alcohol on the water, I will find the total volume is 488. But when I calculate the total volume before mixing, I found it is 500 cubic centimeter. Why it has become 488, not 500 cubic centimeter? Because this is a water. Between the water molecules, this is a water molecules. Between the water molecules, there are intermolecular spaces. So when you put ethyl alcohol on the water, some of molecules of ethyl alcohol occupy these intermolecular spaces, enter between the molecules of the water, so the total volume become 488, not 500 cubic centimeters. So why the total volume of mixture after mixing is smaller than the total volume before mixing? Why? Because some of ethyl alcohol molecules are distributed, are enter between the molecules of the water, or occupy intermolecular spaces between the water molecules. So we can conclude that there are intermolecular spaces among the molecules of the water. So what is the intermolecular species? The intermolecular species, the species that are found among the molecules of the matter. The species that are found among the molecules of the matter called intermolecular species. So give a reason. The volume of a mixture of water and alcohol is less than the sum of their volumes before mixing. Why? Because some molecules of alcohol occupy the intermolecular spaces of water molecules. So the total volume after mixing is less than the total volume before mixing. Number two, disappearance of little amount of table salt when it is put in a beaker of containing water for a period of time. If you have a beaker containing a water and you put some table salt inside it, after a period of time or after a mixing, this table salt will disappear in the water. Why? Because the table salt molecules will occupy or distribute the intermolecular spaces between the molecules of the water, so the molecules of table salt will disappear. So I said this is the property number two of the molecules of the matter. There are intermolecular spaces between the molecules of the matter to approve that if you put water and ethyl alcohol after mixing, you will find the total volume of them after mixing less than the total volume of them before mixing. Why? Because there are intermolecular spaces between water molecule and ethyl alcohol will enter between these intermolecular spaces between molecules of the water, so the total volume will decrease. So disappearance of a little amount of table salt when it is put in a beaker containing water for a period of time, because table salt molecules when dissolve in water, these molecules will spread in intermolecular spaces among water molecules and disappear. Number three, in the properties of the molecules of matter, the presence of intermolecular forces or attraction forces among the molecules of the matter. You have two forces, attraction force and repulsion force. You have two forces, attraction forces and repulsion forces. Between the molecules of the matter, there are attraction force. What is the meaning of attraction force? If you have a molecule and the molecules, there are attraction force between them. They are close together. This is attraction forces. So the type of intermolecular forces between the molecules is attraction forces among the molecules of the matter. To prove that, if you have a piece of iron and you want to break or divide this piece of iron, you will find it is a difficult, or it is a very difficult to break a piece of iron. Why? Because the intermolecular forces between a solid matter, between this iron, is very strong. So in solid, so you will find a difficult to break it. Solid matter like iron, like aluminum, it is a very difficult to break to break a piece of iron or a piece of aluminum or any solid object. Why? Because the intermolecular forces or attraction forces between them are very strong. Number two, it is easy to divide some water molecule. If you have some water, it is easy to divide these water molecules. Why? Because the attraction forces or the intermolecular forces between the molecules of water is a weak, so you can divide it in all liquids such as water, such as alcohol, such as oil. Okay. The gases, the intermolecular forces or the attraction forces between the gases are very weak. So any matter, whatever solid, liquid gases have have intermolecular force or attraction forces between the molecules of the matter. What are the intermolecular forces? The force that bind the molecules of matter together. Intermolecular force or attraction force. Intermolecular force between the molecules of gases almost do not exist. Are very weak. Almost not exist. Okay, so we talked about three properties of the molecules of the matter. Number one, the molecules of matter are in a continuous motion. Number two, the molecules of there are intermolecular spaces between the molecules of the matter. Number three, there are intermolecular forces between the molecules of the matter. Let's start. Let's answer the questions. Let's answer the questions. The attraction forces between the water. The attraction forces between the water molecules is what same between water vapor molecules is less is more than between water molecules than water vapor. Water molecule is a liquid. Water vapor is a gas. So the attraction forces between the liquid more than the attraction forces between the gases. So the attraction forces between water molecules is more than the attraction forces between vapor gas. More than the attraction force between iron molecule is very strong. The attraction force between iron molecule is very strong. Why? Because the iron is the solid, so the attraction force is very strong. So let's let's make a comparison between the three states of the matter, solid, liquid, gas. Number one, in the comparison, solid have definite volume and definite shape. Liquid have definite volume and indefinite shape. Gas have indefinite volume and indefinite shape. Number one, why solid have definite volume and definite shape? Because the molecules of solid, as we talked before, the properties of the solid molecules is narrow or tiny intermolecular spaces. The intermolecular spaces between the molecule of solid is very narrow. The intermolecular forces between the molecules of solid are very strong, so they are relatively fixed in their position, so they have definite volume and a definite shape. So if I ask you why the solid have definite volume and a definite shape, because the intermolecular spaces are narrow between solid molecules, the intermolecular forces are very strong, so they have definite volume and definite shape. Number two, like this is a solid matter, the shape of the solid molecules. Number two, the liquid. We have definite volume and indefinite shape. Why the liquid have definite volume and indefinite shape? because because the intermolecular spaces between the liquid molecules are intermediate or relatively large, and the intermolecular forces between the liquid molecules are weak, so they take the shape of the container in which they are put. This is the shape of the liquid molecule, so the liquid molecules have definite volume and indefinite shape. Why? Because the intermolecular spaces are intermediate or relatively large, and the intermolecular forces are weak, so they have definite volume and indefinite shape. Number three, the gases. The gases have indefinite volume and indefinite shape. Why? Because the intermolecular spaces between the gases molecules are very large, and the intermolecular forces are very weak, so they are completely free. They take the shape and the volume of their container, so they have indefinite volume and indefinite shape. This is give a reason. So if I ask you, give a reason, solid have definite volume and indefinite shape, liquid have indefinite shape and indefinite volume, gases have indefinite volume and indefinite shape. Why? You will answer by the intermolecular spaces and the intermolecular forces. You will talk about intermolecular spaces in these molecules and the intermolecular forces in these molecules. After this, we will talk about the combine. We will make a comparison between the three states of the matter, solid, liquid, and gas. As we said before, the point of comparison, number one, when you have a solid, liquid, and gas, the motion, we will talk about the motion of molecules between or compare between solid, liquid, and gas by the motion of molecules. As I said before, the motion of solid molecules are limited motion or vibrational motion. I can't see it by my eye. Limited motion or vibrational motion. The motion of liquid state are more free or intermediate. The gases state are completely free or unlimited. Another point, intermolecular spaces. Intermolecular spaces between solid are very small or narrow. Intermolecular spaces very small or narrow. Liquid are relatively large or intermediate. Gases are very large. Intermolecular forces between the intermolecular spaces very small. Intermolecular forces are very strong in solid. Between liquid intermolecular spaces relatively large, so the intermolecular forces in a liquid is relatively weak or intermediate. Gaseous state, because the intermolecular space is very large. In gaseous state, the intermolecular forces are very weak or almost not existing. The volume, as we said before, solid have definite volume and a definite shape. Liquid have definite volume and indefinite shape. Gases have indefinite volume and indefinite shape. Some examples of solid: ice, iron, aluminum, copper. Example of liquid: water, alcohol, oil. Examples like gases: carbon dioxide, oxygen, water vapor, the air. Any examples of solid and liquid and gases. This is a comparison between solid, liquid, and gases. So today we talked about the matter consists of the building unit of the matter is molecule, and this molecule is the smallest part of matter which can exist freely and it has the properties of the matter. And we talked about the properties of the molecules and make a comparison between the two states of the matter. Thanks. Thanks so much.